Mars rotates on its axis at the rate of about 0.2552 radians per hour. Approximately how many hours are in a Martian day? Okay, and I think this is supposed to be like the front and back of Mars. So they just took these images at two separate times. But okay, so what do they give us? This radians per hour. That's like the rotation of Mars on its axis. What is this? What is a radian per hour? What kind of number is that? Right? If someone gave us something in a distance per time, meters per second, feet per second, miles per hour, that would be what? That would be like a speed, a velocity. Well, what is a angle per time? No matter what the angle is that's given, or no matter what the unit of time is, that is in all cases, if you have an angle divided per, the units are an angle per a time, that is an angular velocity omega, right? You can use any units you want. On Google can convert anything. So you could take a speed in miles per hour and convert that to light years per day. And Google will give you that. And you could do those unit conversions yourself easily. Unit conversions are easy to do once you get the hang of it. And it's something you should get really good at. Okay, so we have the angular velocity of Mars rotating about its axis in radians per hour. 0.2552 radians per hour, which is technically just per hour. The radians are unitless. Okay, so approximately how many hours are in a Martian day? Okay, so how can we figure this out? Well, let's think about this, okay? Well, let's start with one. Let me bring, okay, omega is, okay, so let's start with 1 day. Let's write that here. 1 day. What does a day mean? What's the meaning of a day in the context of planets and what we're talking about here? What does a day mean? Well, we know a day is a full rotation of a planet about its axis. That's what a day means. It's not about the sun coming up or down. It's technically it's a full rotation of that. Any planet goes one full rotation. That means it's gone through a day. All right. So now we're dealing with angle here. So we can think about a full rotation of a planet. That's 2 pi or 360 or whatever of angle rotated. So we're in radians. So 1 day is 2 pi radians. And even the radians are unitless. I like to put them in the unit conversions because you can see them. You can see the idea that they're canceling. But technically, there's no units here. Okay, so now we've converted. Because we're dealing with they're asking us the speed of the rotation, right? Like you could project all of Mars onto like its equator circle, right? If that's like the equator of Mars, you can think about it's rotating about its that center axis. You could, as far as how long does it take, how fast is it rotating, that you can turn that into uniform circular motion problem, right? They're asking how many hours does it take for it to rotate all the way around. Okay, so all right, so 1 day is 2 pi radians. They're asking for whenever it rotates 2 pi radians. Like how many hours does it take for it to rotate 2 pi radians? That's what we've converted days to radians. Okay, now we know its speed, its angular speed. Okay, so let's bring that in, and we want the radians to cancel, even though that's technically not happening because it's unitless. Radians for every 1 hour. And there we go. Every unit has canceled. We're left with hours. That's what we're looking for. We started with 1 day. We want to go from a Martian day to a certain number of hours. We're converting. What we did was we converted 1 day, 1 Martian day, to hours. That's what we want. So 2 times pi divided by 0.2552. 24.6 hours. So a little bit longer than pretty much the same as an Earth day, but just slightly longer hours. There you go.